we are going into the next part. So in yesterday's class, we saw that there are molecules, isn't it? Each substance is made up of molecules, whether it is a solid, a liquid or a gas. And also we saw that there are substances called as pure substances and mixtures. So what are pure substances? Substances which contains only one type of molecule is called as a pure substance, and substances which contains more than one molecule is called as a mixture. Now we learnt about a mixture, isn't it? So how did we know about a mixture? I took sugar, mixed it with water, and I got sugar solution, and that contains more than one molecule, so it is called as a mixture. And I hope you would have completed the table which I had asked you to classify. Now, in mixtures itself, there are different types of mixtures. Okay, for that we are going to do another small activity. So I am going to do an activity here. Here I have two powders. One is sugar powder, sugar candy which we powdered yesterday. The other one is chalk powder. Okay, so I have two type of powders. Now I am going to mix this in 2 glasses of water. Okay, so in this I am taking little water, and in the other glass also I am taking little bit of water. Now I am going to put sugar into this one. Okay, and I am going to mix it well. We have already done this in the last class, but we will do it once more. So I have mixed sugar, and you know it mixes well. Okay, now I am going to put chalk powder into this. Okay, so here I got 2 mixtures. One is sugar mixture or sugar solution, and other one I mixed chalk powder in it. Now we will keep it for some time and see what happens. Okay, now here in this sugar solution, we all know, isn't it? If we taste this sugar solution, how will the taste of this sugar solution be? Yes, if I taste it from top, it will be sweet. If I go down and take the solution and drink it, this will be sweet. We all know if it is a salt solution or it is a sugar solution, once it mixes together in the water, we know the whole water will be either sweet. If it is salt, it will be salty, isn't it? Now look at the mixture here. What happened here? This is chalk mixture, isn't it? I put in the water and mixed. What happened to this now? We saw, is it mixing properly? No, as we all see, isn't it? What happened here? What happened here? When we mixed it, the whole thing was white in color. After some time, what happened? Only the chalk powder is settling down, you can see, isn't it? So, is this mixing properly, completely into the water? No. Here what is happening? We cannot even see the sugar. So it is completely mixed into the water, and the property of that sugar has reached all the parts of this solution. So if you take from any part and drink, the taste will be the same. So the complete property of the sugar has mixed into it. This what has happened? Here you can see. Now it is settling down top. After some time you can get the water, clear water on top, and only the chalk powder down. So here in these 2 solutions we see that in one it is mixing completely, giving that whole property to the whole solution. Isn't it? The mixture exhibits the property, same property throughout, everywhere. The whole mixture, if you take the same property, it is sweet water. But here what has happened? In different parts, here you will get clear water. Down if you go, you will get chalk powder. isn't it? So the property is not distributed thoroughly or equally to all the parts of the mixture. Okay, the property is not equal on all the parts of the mixture. So different parts, different properties. On top you will get clear water, down you will get pieces of chalk, isn't it? So in this you saw the mixture exhibits the same property throughout. Okay, such type of mixture is called as a homogeneous mixture. What is it called? Homogeneous mixture. That means this mixture exhibits the property throughout. The whole solution has got the same property. But here you can see the whole solution has not got the same property. On top you can get clear water, down you will get little thicker. With chalk powder you can strain and you can get the chalk powder. So the whole solution is not having the same property. Such a mixture is called as a heterogeneous mixture. So what is a homogeneous mixture? The mixture exhibits the same property throughout that mixture. It is called as a homogeneous mixture. In this one, the mixture exhibits different properties to different parts. That mixture is called as a heterogeneous mixture. For example, another one more I will show you. This we know, this is buttermilk. Okay, I made buttermilk here. Now in buttermilk we can see what all things do we put. We put salt, we put chili, we put curry leaves, ginger, all that we put and grind it nicely, isn't it? Buttermilk. But still what happens? Does the whole, all the things, substances mix and become one? No. We can see that even after grinding, you can see many particles will be floating about, isn't it? So if you drink the top part, you will get more of chili and ginger on top. Down if you go, you will not get that taste of that, isn't it? It will be a different taste. On top, when you eat, drink, you will get pieces of all the other things. So here also, the whole mixture does not exhibit the same property throughout. Okay, so this is also a heterogeneous mixture. So what is a homogeneous mixture? A mixture which exhibits the property, same property throughout the mixture is called as a homogeneous mixture, and the mixture that has different properties on different parts of the mixture is called as a heterogeneous mixture. Now one thing what you have to remember is all solutions are homogeneous mixture. Okay, that is salt solution, sugar solution. Okay, all these are homogeneous mixtures. All solutions are homogeneous mixtures. What is a solution? A solute mixes in a solvent, you get a solution. So you cannot see it different. Okay, that becomes another product with many more molecules. So all solutions are homogeneous mixtures. Please don't forget that. So now here we saw the difference between a heterogeneous mixture and a homogeneous mixture. Down you have two examples given there. Lemon juice, Karingali water. We know that, isn't it? Lemon juice and Karingali water. Like that, find out some more mixtures. What are we to do? Find out some more mixtures. After that, make two columns and classify them as homogeneous mixtures and heterogeneous mixtures. So that is the work. What are we to do? Classify them as homogeneous mixtures and heterogeneous mixtures. Now when you go on to the next page of your textbook, you can see different types of solutions. There it is given most of the solution that we use are those in which solid dissolves in a liquid, isn't it? Most of the solution. Now we saw all solutions are homogeneous mixtures. In that a solute will be there, a solvent will be there, which makes it a solution. So all solutions are homogeneous mixtures, and we have seen that in many of our solutions, what is it? A solid will always mix in a liquid and you get a solution. But there are other solutions which exist in other states of matter. That means In a solid, there can be a solution. A solid and a liquid can mix up and become a solution. A liquid and a gas can mix up and become a solution. Only gas can mix up and become a solution. For that, an example is given in your textbook. Look at this table. The solution is given. Brass. Brass is a solution. You know what is brass? A golden color with which you make lamp, velakku and all that if you have at home. That is made up of brass. Okay. Brass. Now, brass is a mixture of what? Two types of metals. Zinc and copper. Brass is a mixture of zinc and copper. Soda. Soda is a mixture of water and carbon dioxide. Okay. Glycerin dissolved in water. Yesterday we saw glycerin. So in that what all is there? That is a solution. Glycerin what all is there? Glycerin is there. Water is there. Next one, air. Air is a mixture of many gases. Which are those gases? Nitrogen, oxygen, carbon dioxide, water vapor, etc. All these hydrogen, many gases are there. All this is a solution. So air is a solution of all these type of gases. So when you look into this table, here you can see, for example, they have already given you brass. What is it? A solid is dissolved in a solid. We thought only a solid mixes in a water, it becomes a solution. But here what did we see? Brass is a solution. What is the mixture there? A solid is mixing in a solid. Second one you take. One more example teacher will give. Other two you have to find out. Soda. Soda is what? Water and carbon dioxide. What is water? Which state of matter is water? It is a liquid. Which state of matter is carbon dioxide? It is a gas, isn't it? So how is the solution formed? Gas is mixing in liquid. So a gas is dissolving in a liquid. You get soda, which is a solution. So the other one, glycerin dissolved in water. What state is glycerin? We know it is a liquid. So write it down. Air. So which are the different other gaseous constituents of the air we know. What is all those things, whether it is a liquid, a solid or a gaseous form. So write it down in your notebook. Okay. So here today we saw two types of mixtures. One is a homogeneous mixture and the other one is a heterogeneous mixture. What is a homogeneous mixture? A mixture which exhibits the same property throughout the mixture is called a homogeneous mixture. And what is a heterogeneous mixture? A mixture in which different parts exhibit different properties is called as a heterogeneous mixture. And we also saw that all solutions are homogeneous mixtures. Thank you, children.